Ready? Lesson 6-4, special parallelograms. Special parallelograms. Each diagonal of a rhombus bisects the two angles AC is the diagonal. It bisects BAD, which means that angle 1 and angle 2 are congruent. It bisects CAD. No, that's not it. BCD. So that angle 3 and angle 4 are congruent. The diagonals of a rhombus are perpendicular. So AC is perpendicular to BD. The diagonals of a rectangle, if you're dealing with a rectangle, are congruent. So in this picture, since it's a rectangle, AC is congruent to BD. Now, a rhombus and a rectangle are two different types of quadrilaterals. A very special kind of quadrilateral is called a square. It has all the characteristics of a rhombus and a rectangle. So if you're dealing with a square, the diagonals are both perpendicular and congruent. Okay? Keep that in mind. If one diagonal of a parallelogram bisects two angles of a parallelogram, then the parallelogram is a rhombus. If the diagonals of a parallelogram are perpendicular, then the parallelogram is a rectangle. If the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. Got that? Find the measures of the numbered angles in the rhombus. So they're telling you it's a rhombus. So you know that the diagonals are going to bisect the angles. It says Theorem 6-9 states that each diagonal of a rhombus bisects two angles of the rhombus. So if the measure of angle 1 is 78, if the measure of this angle is 78, 1 is also 78. Theorem 6-10 says that the diagonals are perpendicular. In a rhombus. So if the diagonals are perpendicular, that tells me that angle 2 is 90 degrees. Because the four angles formed by the diagonals all must have a measure of 90, angle 3 and angle ABD must be complementary. Now what they're saying is, in this triangle, if this is 90 degrees, then the other two angles have to also add up to be 90 degrees. So that angle 3 is equal to 90 minus 78, which is 12. We know that angle 3 is 12 degrees. Okay, finally, because BC and DC are equal, since it's a rhombus, allows you to conclude that angle 1 is congruent to angle 4. What kind of triangle would this be? BC is congruent to CD. That's what they just told me. So what kind of triangle would that be? What's the name of the triangle with two congruent sides? Isosceles. So the isosceles triangle theorem allows you to conclude that angle 1 is congruent to angle 4, so the measure of angle 4 is 78. Remember, in an isosceles triangle, the legs are equal and the base angles are equal. Number 2. One diagonal of a rectangle has a length 8x plus 2. The other diagonal has a length 5x plus 11. Find the length of each diagonal. Well, Theorem 611 tells me that the diagonals of a rectangle are congruent. So, 5x plus 11 is equal to 8x plus 2. What do we need to subtract from each side? So this is 3x plus 2. And then? So 3x is 9. We subtracted 2. What do we do next? Divide by x is 3. Substitute back in to find the length of those diagonals. 8 times 3 plus 2, that would be 24 plus 2, which is 26. 5 times 3 is 15, plus 11 is also 26. So the length of each diagonal is 26. Number 1, find the measure of the numbered angles in the rhombus. Okay. In a rhombus, what do you know about the diagonals in the middle? What happens to them? They are perpendicular. So that means that the measure of angle 1 is 90 degrees. Okay? This angle and this angle are alternate interior, so the measure of angle 2 is 50 degrees. This is also a right angle right here. So if this is 50 and this is 90, what does 4 have to be? 40. The diagonals of a rhombus bisect these angles right here. So if this is 50, angle 3 is also 50 degrees. The diagonals of A, B, C, D are perpendicular. Can this be a parallelogram? So here we go. Let's draw it right here. A, B, C, D. The diagonals are perpendicular. AB is 16. BC is 8. I don't know what that is. These are perpendicular. Can it be a parallelogram? It says use indirect reasoning to show why it can or cannot. Suppose that it is a parallelogram. Then because its diagonals are perpendicular, it must be a rhombus. But if AB is 16 and BC is 8, let's see, went here, y'all. The D went there. Does that satisfy the conditions of a rhombus? No. It contradicts that it's congruent. So can this be a parallelogram? It cannot. Number 2, check your understanding. It says find the length of the diagonals of this rectangle. What do you know about the diagonals of a rectangle? If you can't remember, look back. It tells you that they're congruent. So I know that 5y minus 9 must equal y plus 5. So I need to solve. 4y minus 9 is 5. Add 9. 4y is 14. y is 7 over 2, which is 3.5. Now we got to find the length of the diagonal. Y is 3.5, so I'm going to have to plug that in right there. 3.5 plus 5 is 8.5. A diagonal of a parallelogram bisects two angles of the parallelogram. If a diagonal bisects two of the angles, then it's supposed to be a rhombus. Is it possible for that parallelogram to have side lengths 5, 6, 5, 6? Can a rhombus have those side lengths? Tell me what you know about a rhombus. All of the sides are supposed to be congruent. So does that sound like it's going to work? No. Okay. We're on page 315. And that's your assignment. 1 through 9 all, 10 through 14 even, 48, 49, and 50.